Hello, everyone. I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Illinois. This video today is going to look at the Python programming language, and we're going to use that as the review for your programming review problem. That is, at least from me right now, was due last night at midnight for about 10 hours post-due. So here is the video that covers this information. So I found a Dr. Barker video. I don't know how popular Dr. Barker is, but I found a video and it was interesting to watch, and I kind of tweaked that around to find a fun problem where you're on a golf cart. You're taking a golf cart road trip through the prime planes. The part of this problem will be deducing how to deduce if a number is a prime number. And so, but what's going to happen is you're going to be traveling and you use 2.125 units of fuel per mile traveled. And the goal is basically to figure out if I do that, and at every odd prime number I get more fuel, then how far can I go? And if you do it right, according to Barker's video and my proof through writing code, is you can go through the entire prime planes forever. You can go forever. But if you do not have a certain amount of fuel to start with, you will halt all the way out there. And the question is, how far out? What is the furthest spot where I can halt before moving on? That's part of the problem. Okay, so before we talk about prime numbers, before we talk about anything else, let's just say I'm starting at mile marker 0, and I know that the amount of fuel I have, I've just got to make up a number. I'm just going to say 7, like I have down below here. And so while my fuel is going to be greater than some number, and that's the final thing here, is I'm just going to put it in all caps here, fuel burned per mile, and it's all units. It's not gallons or anything like that, because that would be, well, maybe the prime plains very hilly or something like that, and it takes 2 gallons of fuel. But anyway, I digress with that. But as long as the fuel that I have right now is greater than or equal to the amount of fuel burned per mile, then I can go a mile, right? I can go a full mile. And so mile plus equals 1. Fuel minus equals the fuel burned, right? I mean, this makes sense so far. And I can also print out, I'll do a print here. I'll do mile. I'll do it with the formatted string. So mile, colon, distance, or fuel. How much fuel is left? Fuel. And so let's try that out. So let's see what happens. Pops up. Will I get an error? Oh, I'll have to bring this up a little bit. I forgot that it doesn't run in a window. Excuse me. So miles 0, fuel 7. Not exactly what I was expecting. I was expecting it to go a few more times. Let me try this one more time. Maybe I misunderstood something. No. So something is out of, because I didn't print inside of here. I just am not doing anything right. So there we go. So coming back to this, oh, come on. Go. Now you can see there, at mile 0, I have 7 fuel. But every mile I'm subtracting off 2.125, and when I get to mile 3, I have a little bit left over. And so I can't go the full mile, so I'm done. And so I would be right around mile 3 1/3, is like, because I can drive through there. Like I'm saying, there's nothing saying that you stop at a mile where you can't continue on. So at this point, if I had 7 fuel, I would have about 3.3 miles before I could go and ask for help, try to get me out of this situation, because the prime planes are a very, very, very dangerous place. So, Venice, whatever, all those villains from all the movies you've ever thought about, all of them live there. And the second you step foot off, you are a goner. Okay, so that's the first part of this. So then the second part of this is to figure out, is a number an odd prime? And so the value is, or the algorithm is identical to anything you've ever heard about when it comes to determining if a number is prime number or not. The only difference is, what is an even prime? The only possible even prime is the number 2. So the whole point of this is just to say if I eliminate 2 from the list of prime numbers, everyone else has to be odd, and so that's where we're going for here. So as long as I say, as long as my n value is less than or equal to 2, I can return false. I don't have to do any extra work. I can just say any negative number is not prime, 0 is not prime, 1 is not prime, and in this case, 2 is not prime. That is not normally the case, but it is the case here for this example here. And so, what I'm going to write here is not the most efficient thing ever, but it gets the job done. It gets the job done. It's described better logically, from an educational standpoint. So I say, what do I have to do? I have to try every index value, or I have to try I have to divide, like if it's the number 5, I have to divide it by 2 and see what the remainder is. Divided by 3, divided by 4. And again, I know the square root is the best way to do things, but I don't want to complicate too much for those of you who are already in the know. But all I want to say is in the range of 2 to n. So that is, I'm going to try dividing by 2 up to, and not including the number itself. I know this range thing can get, just the way the range works, that it looks like I might be trying n divided by n, but I'm not. This goes from 2 to n minus 1 if n mod index is equal to 0. I'm going to return false, because if I take my, let's just say 8, and I divide it by 2, and what do I get? I get 4 remainder 0. That means that 2 is a divisor of 8, and that means this is not a prime number at all. And I guess I could also range this by, no, I can't range this by 2. Well, whatever it is. But anyway, so just to say, I'm going to return false because I found something. And if I go through the whole list of numbers and I don't find anything, then I'm going to return true. So that is the whole idea of how the odd function works. Get rid of the only even, test out all the divisors, and if you don't find one, then you have to have an odd prime. So then now what I do here is I always subtract off, and I say now if is odd prime, whatever mile I'm at, then I'm going to do this. I'm going to add fuel. Whatever mile number I'm at, that's the amount of fuel I'm going to add. And I'm going to print out everything another time. Here, let me make this bigger now that we know the problem here. Guys, sorry for all the, there we go. And so now let's see what happens starting from mile 7. Or I'm sorry, with fuel 7. Now you can see when I get to mile 3, I do get that. And, oh, that's interesting. 5 is supposed to be odd. Oh, I didn't get enough fuel. I still don't have enough fuel when I get to mile 4 to get to mile 5. So things kind of just halt there. So, and one last thing, just to say here, just the final step here. Where do I get to? Where do I halt at, I guess, is what if you want to think about it. I can say mile plus fuel, let me put that in parentheses, fuel divided by the fuel burn per mile. Oops, not going to do it for me. Okay, never mind, I'll write it out. So this will tell me exactly how far things will go. Because you can see I got 1.5 fuel left. If I take 1.5 and I divide that into 2.125, I get right around 70%. Which makes sense if you just do the quick math. Just to say, what is 1.5 divided by 2.125? And ta-da, there you go, 7.70588, blah, 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 blah. So, okay, so this will tell me at the end of the day where I'm at. So now, with all of that said and done, now I have to go ahead and find the spot where, because this halts, find the smallest value where I don't halt. Because if I put in 18, you will see that this thing runs forever. And because of the Barker video, that proves that I never have to worry about running out of fuel ever again. Once I can kind of get going, get my steam, nothing's ever going to halt. Nothing's ever going to stop me. And that's just part of the way that prime numbers work, and you can watch that video if you're interested. But there will be a point where it goes from that value of negative, or sorry, when it goes for that, it will halt at some point to the place where it will never halt ever again. So you're just gonna keep on trying. 8 halts. 8.25 halts. 8.5 goes forever. Okay. 8.35. Okay, that halts. 8.4. So that goes on forever. So I'm working my way down. This is an experiment. So I say, okay, 8.375. That goes forever. But 8.374, that halts. So the number that we're, and if you go here like this, if you make this 8.7 blah 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 blah, you see that it halts. But so this is the answer to the problem. 8.375. That's how much fuel I need to start with to make sure I never have to worry about fuel ever again. If I got more than it, it's great. But if I've got less than that, even one drop less, I'm in for a world of hurt if no one can come and save me. Even that one tiny step out of the cart will get me eaten by every bad guy ever that you've ever imagined. That's the worst fear ever. Everything that you've ever feared will come and get you in that one brief moment. That sounds very dark. Well, it's been a very dark couple of days for me. But anyway, so that's part one of the problem, is trying to work your way down to figure out where you're supposed to go. And I get 8.375. And you can see now part two, because of the way I set the problem up, is actually quite easy. Because all I have to do is, okay, part one was finding the fuel value. But I said if you take one drop out, where do I end up? And you can see that I end up right before mile 11. 10.99999, like basically the limit of, the closer, and I know because we're dealing with computer science math, we're dealing with doubles, that it will never show you, but the closer you get, but not touching 8.375, the closer to 11 you will get, but you'll never reach 11 because 11 is reached when you hit 8.375. So the answer to part one is 8.375. And the answer to part two is just under 11, so 10.999 repeating, but not quite there. That's what a limit, kind of like with the limit problems, if you've ever dealt with it, and you will have to deal with some calculus to complete your degree program, either here at C or at Lewis University, or wherever it is that you end up. Okay, so that solves this problem in Python. I'm going to do the same thing in C++ for those of you who are more apt to C++, but I figure you guys are becoming fourth-year students here. You should definitely know both languages. You should know a loosely typed language and a tightly typed, oh my god, a couple of days. A loose language and a more strict language when it comes to typing and this kind of stuff. Because Python is a fun language. It gets you a long way. Sometimes I still want to fall back on the things I know in C++. Plus, it's a little faster, even with NumPy and all that stuff. Okay, rambling off. If you have any questions or if I misspoke about something, please comment below or email me at swardb@cod.edu. Thanks for sticking it out with me as always. Have a great week. I will see you in a future video, I hope. Take care, everyone.